Okay, welcome to Tuesday. It's the first day back after a long weekend. I left you on Thursday by having done some questions from the second assignment, assignment 2, which was about quadratic applications. And I think I'm going to continue on before starting assignment 3. I'll just finish up 5 and 6 today, and then we're going to do lesson tomorrow. Once again, if I just go back to the previous page, our applications of quadratic functions involved either being given a graph or being given the equations, which that's very easy. We just punch this into our calculator, or be given the table of value. That's pretty easy as well. It just involves a little more work on your part, but you're given the table of values, and then you develop the equation. And that's what number 5 is about. Again, number 5 is given a table of values, entering this into your calculator and developing the equation. Once you have the equation either given to you in the question or you develop it in your calculator, everything is straightforward after that, right? It's just coming up with the equation that's the hard part. Example number 5. The story is, it's the water fountain at Portage Place. It shoots water into the air. At regular intervals, the following data was recorded. So they are recording the height of the fountain spout. You know how the fountain sprays water up into the air? And then typically what happens is the water droplets then fall down to the ground, and that the pattern that the water droplets make parabolic. So we're recording the height of the water over time. So here's my data. So I've already cleared my calculator out, and please clear your calculator out of any old data. And let's see if I can move this onto the page and you can see everything. Okay, so now I'm going to turn my calculator on. I'm going to go into Stat Edit. I'm entering my data. This is my list 1, right? This is my X coordinate, my Y coordinate, list 1, list 2. So I enter in 0, 0.5, 1, 1.5, 2, 2.5, and 3. And now I hop over to the next column, and I'm going to enter all my Y values in. A -1, 4, 9, 11, another 11, an 8, and another -1. Okay, my data is entered in. This data is not that large. It's a little larger than 10, but let's just turn our stat plot on. So second Y equals, and turn your stat plot on. Just hit enter till it's on. Let's press graph and see what we can see. So I can see most everything, right? Maybe let's just increase that window a little bit, the Y max window. Let's just increase it to like 15. Okay, so now you can see that nice parabola forming. Now these are just a collection of 2, 4, 7 points. I don't want just 7 points. I want all the points. To get all the points, I need to collect or create an equation that will model and fit this series of points. So how that is, I go to Stat again, and now I want to get into Calculate mode. And I recognize that it's a quadratic. So that's my big decision, right? Recognizing it's quadratic. And now I'm just going to go to my store function because I want to store all this data in the Y equals. So I have to do that. The var stands for variables. Once you go through all those steps, which are outlined in your linear equations unit, here's the equation that I've developed. So find the quadratic regression equation. Okay, the quadratic regression equation is Y equals, now they give me the A and the B and the C values, and I have to substitute that into the appropriate spot in the equation. So I have to substitute the A into the appropriate spot. So it's going to be -5.43, I'm rounding to 2 decimals, x squared, plus 17x Now the C is negative, right? It's a -2, so I'm just going to put the -2 down. Okay, so there's my equation. That is the most important point. Even more importantly, what you did there is you pasted it into the y=, screen with all that series of steps. It's now sitting in my y= screen. Anytime you have an equation pasted into your y= screen, you know that it's going to, the line is going to form, right? And there I can see the line going through the data, or the curved line going through the data. And once I have the curved line going through the data, I can answer any question they throw at me now. So let's see what part B asked for. Part B asked for, what is the maximum height reached by the water? Okay, I know how to do that, right? I'm just going to move my calculator up again. So second trace, and I'm going to pick max. And now I just have to, I can see the pulsar, it's pulsing here. I have to move it a little to the left of the vertex and enter. And move that pulsing cursor to the right of the vertex and hit enter. And now they're asking me to take a guess, which I do. And it gives me that the maximum, it's asking for the maximum height. That's the y value. So the maximum height is 11.31. And I believe that is meters. Yeah, meters. And then the next question was, how long does it take till it reaches this maximum height? So that occurs at, like, the y value is the height, the x value is the time. This occurs at 1.57, if I round properly, seconds. Okay, just going to move my calculator out of the way for a sec. How much time does it take until you can actually see the water for the first time? Okay, well, let's think about that. If I do a quick sketch here, and if I'm just kind of, it looks like this is height in meters and time. So this water spray is coming up. It really kind of looks like it's coming out of the corner, but basically it's where the height of the water first starts to leave the ground. So that's that's an x-intercept. So we have to put in equals 0, right? And then let's do our second trace, number 5. And I'm just going to move it kind of close to where I think the water's just starting to come out of the ground. And I guess that occurs at 0.12 seconds. So at 0.12 seconds. So it's not right at 0 seconds. It actually, the fountain runs for a little while before the water spurts out. For how many seconds is the water visible to bystanders? Okay, so for part E, the water is spurting out, right? And then it comes back down and then it stops. So basically I'm finding the difference, the distance between the two x-intercepts. So I'm going to just move over here. Find the difference, or find the distance, or difference, because that's what I'm going to be doing, subtracting, between the two x-intercepts. Okay, so the first x-intercept was 0.12 seconds. I still have my calculator set up to find the second one, right? I have my y= entered in. And I'm going to go second trace, number 5 again. Okay, so I'm sitting at my first x-intercept and I want to move all the way over to my second one. I'm going to answer the 3 questions. And I get 3.01. All right, I'm going to move that over. So this second one is 3.01. So I'm just going to take 3.01, take away 0.12. And that's going to give me 2.89 seconds. Okay, so how many, I'm going to say 2.89 seconds. And then finally, when does the water reach a maximum or reach a height of 10 for the first time? Well, I know the maximum is, what was it? The maximum is 11.3. So 10 meters, the maximum height is 11.3. So 10 is going to be about here, right? That's why they're saying for the first time, because it actually reaches 10 meters twice, right? Once on its ascent, when it's climbing in height, then it reaches 11.3 and then it drops again. So it actually reaches 10 meters twice, but we want this spot. Okay, so that means I'm going to move my horizontal line up. Right now I have a y equals 0. I'm going to move my horizontal line up to 10 from 0. Okay, so we're going to do this. I'm going to put a y equals in of 10 this time. I don't need 0, I need 10. And then second trace, number 5. So this time we get our curve, and then we get our straight line going through. And I have to move my cursor up to the first 10 meter. Answer my 3 questions. And the first time it hits 10 meters is at 1.07 seconds. Okay, so in 1.07 seconds. All right, so that was a nice refresher. That kind of did a little bit of everything, right? We had to enter our table of values in, develop the equation. We had to find the maximum and know what that represented. We had to do some work with some x-intercepts and figure out 2 different x values for 2 different y values. That was a nice, good summary question. Let's go into the last question. It's still a table of values, you can see, but it's not an easy table of values. This first table of values and number 4 before it, they gave us all the values. This is the toughest type of table of values. Obviously, we have to create our own table of values. And we're generating a 3-column chart, but we know in our calculator, we only enter in 2 columns of data. So we have to figure out which columns to enter in. And the question will usually tell you though. So let's see, let's read. The manager of a bike store is setting the price for a new model. Based on past sales, he predicts he can sell 280 bikes if the price is $360. Okay, so if it's $360, he can sell 280. For every $10 increase, he expects to sell 5 fewer bikes. And this is his revenue, right? Obviously, if the price is $360 and he sells 280 of them, he's going to make this much money. Okay, so it gives us this clue or this important piece of business modeling. For every $10 increase in price, so if I increase this by $10 to $370, I can sell 5 fewer bikes. So I'm not going to sell 280 anymore. I'm going to sell 275. And you might think, well, why would you increase the price if you're going to sell less? Well, with that price increase, though, you might end up making more revenue, right? You have to. This is what's called a business decision, and you're trying to figure out the maximum price. Now, this doesn't always work, by the way. It works most of the time that if you drop the price, you'll sell more, and if you raise the price, but for the most part, when you raise the something, typically fewer people can afford it or will value it as much, and you'll get fewer sales. So let's complete these next 2 rows. Okay, if I do another increase in price, I'm going to sell 5 less. I'm going to be down to 270 sold. And finally, if I bump it to 390, I'm going to only sell 265. Now, you could have used different numbers, right? But just for me, it's easier just to keep adding on 10, 10, 10. I could have added on like a $20, but if I would have had to decrease my bike sales by 10 then. All right, now I'm going to figure out my revenue, because obviously I have to figure out this chart as well. Clear your calculator from your previous entries, by the way. And let's just figure out these numbers. So 370 times 275 is 101,750. And then 380 times 270 is 102,600. And 390 times 265 is 103,350. Okay, so now I've completed my 3 tables. I only can use 2 of these columns now though. So which 2 columns am I going to use? Let's read the question. Determine the equation that models the revenue as a function of price. So I want revenue and price. Okay, I'm not going to be using this column. They want me to just punch in revenue as a function of price. So those are my 2 sets of data that I'm going to use. All right, I'm just going to move my calculator over. Just going to do this. So I'm going to go back to edit first to get all my values in. So I'm entering in price and revenue. So 360, 370, 380, and 390. And I get 100,800. Whoops. Okay, so I have my data in. There was just four points, 4 coordinates. So I'm going to turn my stat plot on. And I'm going to enter my, I think I'm going to put an X-min of like 300. I might just try this X-min 300. X-max, I don't know. I'm going to put 600. And I'm going to put Y-min. It looks like I'm going up, right? But I'm going to put Y-min, I don't know, 90,000. Because I only have part of the data here. And I'm going to put Y-max 200,000. Just kind of playing with numbers just to see if I can see my, my data. All right. The nice thing about tables is you have an idea of what numbers you're looking at, right? And what numbers you can set your windows at. I know that I'm going to at least see some of my values with these windows. I might have to adjust my windows as I go along. Ooh, I didn't need all that, right? Maybe I'll reduce my 200,000 to like 110. Okay, I'm going to reduce that to 110,000. That's better, right? It looks like it's just creating that little arc. Okay, that's what I mean. Your windows are very flexible. You can go back and attempt them many times. Now let's get our equation going. So I want to calculate. They told me it's quadratic and I can see that it's quadratic. Now I have to store, I want to store my data in that y equals. So I have the nice curve that forms and goes through the points. So vars, y bars, and just keep pressing enter. So here's my A, my B, my C is 0, which means I don't really need to include it. Y equals negative 0.5 x squared plus 460x. And if C is 0, I don't have to include it. What price will yield the maximum revenue? Well, remember, this is your X value. This is your Y value. X is price. So what price will you? So I have to figure out what my maximum is, right? Let's take a look at the graph again. Because we did our paste function, we have our nice curve and we can answer any question they throw at us. So second trace number 4. All right, I'm just going to move it a little left of that. So that's my left marker. Then I move to the right. That's my right marker, and I take a guess. So the maximum value is 105,800, and the price would be $460. And 0 cents, right? Because that would just round to 0. What is the maximum amount of revenue? Remember, the X value is the price, the Y value is the revenue, so it's sitting right there for me. 105,800. I guess I can put my .00. And that's it. So it's really knowing the steps overall, right? What steps to take, but the steps themselves are so repetitive that it almost becomes almost hypnotic when you go through these steps again. And they were essentially the same steps we learned in the linear functions unit. The only difference is when we go to when we actually go to calculate the equation, we're choosing quadratic instead of linear. And then part of your job too is to recognize if you were just looking at a scatter plot, a plot of data, you should be able to recognize the difference between a linear and a quadratic scatter plot. So that's it for today. I think, like I say, at least that kind of gives you an idea if you were struggling with some of these questions about the answers to all of them. Tomorrow, I'm going to start the last lesson for this unit, systems of equations. And that's an interesting lesson because that actually talks about graphing two different functions on the same grid. Now, we've seen that already when we found our x-intercepts. We're actually graphing two equations, and a y1 and a y2. But this time we're going to explore some more interesting looking equations than just a straight horizontal line. So that will be tomorrow. Try and finish up any outstanding homework. Please email me any questions you have, and I'll talk to you tomorrow.